Top 6 AI agent concepts every IT professional should know. Now let's understand the first and probably one of the most important concepts behind modern AI agents, Model Context Protocol or MCP. Think of MCP as the USB-C standard for AI. Okay, so years ago, every phone had a different charger. Integrating devices was messy because every manufacturer used its own connector. Then USB-C came along and standardized everything. MCP is trying to do exactly the same thing for AI systems. Instead of building custom integrations between an AI model and every application like GitHub, Jira, databases, cloud storage, or enterprise APIs, MCP provides one common protocol that everyone can follow. Okay. At the top, we have our AI agent or large language model. By itself, the AI only knows what it was trained on. It cannot directly access your company's database or your GitHub repository. Okay. This is where MCP comes in. MCP acts as a communication layer between the AI and external systems. It defines exactly how the AI requests information and how external systems respond. Instead of creating hundreds of custom connectors, developers can simply implement the MCP standard. Okay. On the left, you can see the data sources. These could be SQL databases, vector databases, document repositories, or internal knowledge bases. In the middle, we have tools and APIs. These allow the AI to perform actions like running code, sending emails, querying APIs, or creating tickets. And on the right are external services. These could include GitHub, Jira, Slack, Google Drive, AWS services, or any third-party platform. So what are the advantages of MCP? First, it defines standard way for AI models to request and receive context. Second, it enables secure integration because every interaction follows a structured protocol. And third, it makes AI agents tool agnostic. Today, your agent can connect to one database. Tomorrow, you can swap it for another system without changing the AI itself. Imagine you are asking an AI coding assistant, find the latest bug in our payment service and create a Jira ticket. Okay. So the AI would use MCP to connect to GitHub, retrieve the latest code changes, analyze the issue, connect to Jira, and automatically create the ticket. The AI is not directly hard-coded to GitHub or Jira. It simply talks through the MCP standard. Okay. So whenever you hear something talking about AI agents connecting to enterprise systems, remember this. The AI provides intelligence, MCP provides connectivity, and together they enable AI to interact with the real world. Now that we understand how AI connects to external systems using MCP, let's look at one of the simplest AI agent designs, the single agent architecture. A single agent architecture means exactly what the name suggests. One AI agent is responsible for understanding the request, making decisions, using tools, accessing memory, and completing the task. Everything starts with the user. The user provides a goal or instruction. For example, generate a weekly sales report and email it to my manager. Okay. The request then goes to a single AI agent. This agent acts like an employee who can think, plan, and execute. Instead of multiple specialized agents collaborating, one intelligent agent handles the entire workflow. Okay. The AI agent can use external tools and APIs whenever it needs additional capabilities. For example, it might query a database, call a REST API, search internal documents, execute code, or send an email. The AI doesn't need to know everything itself. It simply uses the right tool. Okay. The agent also interacts with memory. Memory helps it remember previous conversations, user preferences, completed tasks, or important context. For example, it may remember that you prefer PDF reports instead of Excel files. This makes the AI feel much more intelligent and personalized. Okay. So why do many companies start with a single agent architecture? First, it's simple and easy to build. You only need one AI agent managing the entire process. Second, it's perfect for well-defined tasks where the workflow is relatively straightforward. Things like generating reports, summarizing documents, answering customer questions, or automating routine tasks. Okay, but there is one important limitation. As the complexity of the problem grows, one agent can become a bottleneck. Imagine asking a single person to act as a researcher, software developer, tester, architect, and project manager all at the same time. Eventually, performance and scalability become challenges. That's why larger AI systems often evolve into multi-agent architectures, which we will discuss next. Okay, let's discuss one single agent architecture example. Imagine you ask your AI assistant, analyze yesterday's application logs and email me a summary of any critical production errors. The single AI agent would understand your requests, access the log database, analyze the errors, generate a summary, use the email API, send the report. One AI, one workflow, and one decision maker. Okay. Now let's talk about one of the most important concepts in AI agents, skills. Think of skills as the superpowers of an AI agent. Just like humans learn different abilities such as writing, coding, searching, or analyzing data, AI agents can also have specialized capabilities called skills. These skills allow the agent to perform specific actions whenever needed. Okay. At the top, we have our AI agent. The agent is responsible for deciding what needs to be done. But instead of doing everything itself, it can invoke different skills based on the task. For example, if the agent needs the latest information from the internet, it can use a web search skill. This allows the agent to search websites, documentation, news articles, or knowledge bases. If calculations, automation, or programming tasks are required, the agent can use a code execution skill. This enables the AI to write and execute code, processes files, and automate workflows. Okay. If large amounts of data need to be analyzed, the agent can activate a data analysis skill. It can identify trends, generate reports, and extract insights from datasets. And if the final result needs to be delivered to someone, the agent can use an email sending skill. The AI can automatically compose and send emails. The real power comes from combining multiple skills together. The agent doesn't just use one skill, it selects the right skills at the right time and orchestrates them into a workflow. When all required skills finish their work, the task is completed. The user doesn't see the complexity happening behind the scenes. They simply receive the final results. So let's see one example. Imagine if you ask, find the latest AI news, summarize the top 5 stories and email me the report. The AI agent would use web search to find news articles. Okay, one skill used. Use data analysis to identify important stories. Another skill used. Generate a summary. Okay, another skill used. Use email sender to deliver the report. So then another skill used here. So multiple skills, one agent, one completed task. Okay, an AI agent is like a project manager. Skills are the specialists. The manager decides what needs to be done and the specialists perform the work. So remember, a skill is a reusable capability that allows an AI agent to perform a specific action. The agent provides intelligence, the skills provide execution, and together they perform AI from simply answering questions into actually completing tasks. Okay, so far we have seen a single agent architecture where one AI agent performs the entire task. But what happens when tasks become too complex for a single agent? That's where multi-agent architecture comes in. At the top, we have the manager agent. Think of this as a project manager or team lead. The manager agent doesn't do all the work itself. Instead, it coordinates other specialized agents and delegates tasks to them. Okay. The first specialist is the research agent. Its responsibility is gathering information. This agent can search documentation, databases, knowledge bases, websites, and enterprise systems. Its only job is finding relevant information. Once information is collected, it moves to the analysis agent. This agent processes the data, identifies patterns, performs reasoning, and generates insights. Think of it as the analyst on the team. The final specialist is the execution agent. Its job is taking action. It may create Jira tickets, send emails, deploy code, update databases, or execute workflows. Okay. All agents share a common memory and knowledge layer. This is extremely important. Instead of every agent maintaining separate information, everyone accesses the same source of truth. This ensures consistency and collaboration. The agents continuously communicate with each other. The research agent shares findings, the analysis agent shares insights, the execution agent reports results. Together, they function like an intelligent team. Imagine you ask, analyze customer complaints from the last month and recommend improvements. Research agent collect customer feedback, retrieve support tickets, gather survey results. Okay. Analysis agent identify patterns, find recurring issues, rank problems by severity. Execution agent generate report, create improvement recommendations, email stakeholders. And manager agent coordinate everything, track progress, deliver final results. Okay. Instead of one AI trying to do everything, multiple specialized AI agents collaborate to solve the problem. Okay. Now see single agent versus multi-agent. So single agent, it does everything, only one agent. Many tasks has to be performed by one single agent. Okay. And here you see, instead of one agent doing everything, responsibilities are distributed. That is multi-agent architecture. Okay. Now let's see one use case. Investigate production outage. Okay. Each agent contributes its expertise. You can see on the screen. This is why multi-agent systems are becoming popular in software engineering. If you have worked in a software team, we have already understood multi-agent architecture. So you can relate from here. A single agent system is like one developer doing everything. A multi-agent system is like an entire software team collaborating toward a common goal. Multi-agent architecture divides work among specialized AI agents that communicate, collaborate, and share knowledge to solve complex problems more efficiently. Now let's see the advantages of using multi-agent architecture. Just like a software team has developers, testers, and architects, a multi-agent system assigns different responsibilities to different AI agents. Each agent focuses on what it does best, improving efficiency and quality. These agents don't work in isolation. They continuously exchange information, share findings, and collaborate to move the task forward, much like members of an engineering team. When tasks become too large for a single agent, work can be distributed across multiple specialized agents. This enables faster execution, better scalability, and more effective problem solving. Okay, by distributing work across multiple agents, complex tasks can be handled faster, more reliably, and at a larger scale. Okay. So far, we have explored AI agents, skills, and multi-agent systems. Now let's look at one of the most powerful concepts in modern AI applications, Agentic RAG. RAG stands for Retrieval-Augmented Generation. Traditional RAG retrieves information and uses it to generate answers. But Agentic RAG goes a step further. Instead of simply retrieving documents, the AI agent actively decides what to search, where to search, and how to use the information. Okay. So everything starts with a user question. The user asks something that requires up-to-date or specialized knowledge. For example, what are the latest AI regulations affecting financial institutions? Okay. So this is what user is asking. So now the AI agent acts as the decision maker. Instead of immediately answering, it first determines what information is needed and where it can be found. Okay. So now see step by step. Step 1, retrieve. The first step is retrieval. The agent searches through relevant sources such as company documents, databases, websites, APIs, or knowledge bases. Okay. And the next step is relevant documents. So here, the agent gathers the most relevant information. Rather than using everything it finds, it filters and selects only the documents that are useful for answering the question. Now, step 3 is reason. This is where agentic RAG becomes different from traditional RAG. Okay. So understand this. This is very important point. When you see you already have traditional RAG, then why agentic RAG? So this is the main difference. The agent doesn't just retrieve information. It analyzes reasons, compares sources, and determines how the information should be used. So retrieval provides facts, reasoning provides intelligence. It will utilize the intelligence and see what exact information can be used. Okay. Next step 4 is generate answer. Once the agent has gathered and understood the information, it generates a response. The answer is grounded in real data rather than relying only on what the model learned during training. Okay. So let's see one example. Imagine you are an engineer and you ask, why did our payment service fail last night? Okay. The AI agent searches logs, monitoring dashboards, and incident records. It then reasons over all the information and provides a complete root cause analysis. Okay. Now let's see why agentic RAG matters. Without retrieval, an AI model can only answer based on what it learned during training. With agentic RAG, the model can access fresh information whenever it needs it. This significantly improves accuracy and relevance. So now let's see the benefits. Retrieves relevant information. Agentic RAG connects AI to external knowledge sources, ensuring answers are based on current and relevant information. Okay. Combines retrieval and reasoning. The agent doesn't stop at finding information. It evaluates, connects, and reasons about the information before producing a response. Generates accurate, up-to-date responses. Because answers are grounded in real data, responses are more reliable and less likely to contain outdated information. Traditional LLM versus agentic RAG. So traditional models answer from memory. Agentic RAG answers using fresh information. So traditional AI is like answering an exam from memory. Okay, you are sitting in the exam, so whatever you have prepared and you have in your memory, you are writing your answers. Okay, but agentic RAG is like taking the exam with the access to books, documentation, and the internet, and knowing exactly where to look. So you can understand the difference. You are not only answering from memory, you are using the current information. You have access to the internet, you have access to the books and everything, and you use that current information and then answer. So that is agentic RAG. Agentic RAG combines retrieval, reasoning, and decision making to help AI agents find the right information, understand it, and generate accurate answers. So far, we have discussed AI agents, skills, multi-agent systems, and agentic RAG. Now let's talk about something that makes AI agents truly intelligent over time: memory. Without memory, an AI agent starts every conversation from scratch. With memory, an agent can remember information, maintain context, learn from previous interactions, and provide a more personalized experience. Okay. So let's see what is memory. Memory is the component that stores information, past interactions, observations, and agent experiences. Think of it as the brain's storage system. Just as humans remember past conversations and experiences, AI agents use memory to make better decisions in the future. Now, let's see from the top. We will discuss one by one all of this: user interactions, observations, tool outputs, etc. Okay, so let's see user interactions first. Memory receives information from user interactions. This includes conversations, commands, feedback, and actions performed by the user. Okay. Memory also stores observations. These could be environment data, monitoring information, application state, or external events observed by the agent. Okay. Whenever agent use tools, APIs, databases, or search systems, the results can also be stored in memory for future references. All of this information flows into the memory system. Okay. The memory system becomes the knowledge source that agents can access whenever they need context or historical information. Now let's see short-term memory. Short-term memory stores information for the current session. It helps the agent remember what has already been discussed during an ongoing conversation. For example, user says generate a report, later says add charts to it. So the agent understands what it, when we say it, add charts to it. So what is it here? What we are referring to it here? So that agent can understand from this short-term memory, which is the ongoing conversation is happening. So the agent can understand like what this it means. So the agent understands what it refers to because it remembers the current conversation. Okay. Long-term memory persists across sessions. It allows the agent to remember important information even after the conversation ends. For example, user prefers PDF reports. So agent will remember this, and whenever any report needs to be generated, so it will generate in PDF instead of in any other format. Okay, because it's in the memory. The next time a report is requested, the AI can automatically generate a PDF without asking again. Now let's discuss knowledge base. A knowledge base stores facts, documentation, policies, architecture diagrams, and business information. This gives agents access to organizational knowledge. Okay. Vector store. For semantic search and retrieval-augmented generation, AI systems often use vector stores. Vector stores help find information based on meaning rather than exact keywords. Okay, for example, payment, timeout, issue. The system can retrieve related incidents even if the exact words are different. Okay. Preferences and profiles. Memory can also store user preferences and profiles. This allows AI systems to personalize responses and automate repetitive decisions. Now let's see the benefits. Includes short-term and long-term memory. Together, short-term and long-term memory help agents understand both the current conversation and historical context. Okay. Memory prevents the agent from repeatedly asking the same questions and helps maintain continuity across interactions. Improves personalization and continuity. By remembering preferences, behavior patterns, and past interactions, AI agents can provide a more personalized and efficient experience. Okay. Let's see one real-world example. Imagine you interact with an AI assistant every morning. On Monday, you ask to generate a production health report and send it as a PDF. The agent stores this preference in memory. On Tuesday, you simply say generate today's report. The AI already knows which systems to analyze, which format you prefer, who should receive the report. That's the power of memory. Think of memory like a trusted college. You don't have to explain everything again every day. They remember your preferences, your projects, and the context of previous discussions. AI memory works in a similar way. So remember, memory allows AI agents to retain information, maintain context, learn from interactions, and deliver personalized experiences. Without memory, every interaction starts from zero. With memory, agents become smarter, more helpful, and more human-like over time. So memory is what transforms an AI agent from a simple assistant into a continuously learning and context-aware partner. If you like this tutorial, then don't forget to like, share, and subscribe, and keep watching TECVKY for more technical content and learn AI and build your future.